Okay, we are going to continue on with some modeling problems. This first problem that we're going to do actually uses a linear modeling problem that was earlier in this section, so if you need to look back at example 3, you can. But essentially, the model from example 3 is a function in which x is the price per box of cereal and y is the number of boxes sold. This model can help us kind of compare the two. So we're going to use that model, from the example to develop a model for the weekly revenue generated by donut-shaped oat breakfast cereal sales. Determine the maximum revenue and how to achieve it. So if x is the price per box and y is the number sold, we could find our revenue by multiplying the price per box by the number of boxes sold. Okay, so essentially I'm going to take the price per box and multiply it by 15,358.93x plus 73,622.50. Okay, and I can simplify that by distributing. So I have an x squared in there, and then x. Okay, so this is our function that we're going to work with here, and we're going to find the maximum. So really what you can do is, since you have a quadratic here, we can flip over to our graphing calculator and enter this into our graphing calculator for our first function. So we have, I think I was missing a negative sign in that original problem. Hang on. Let's go back to the original problem because there is a typo here. Squeeze a negative sign in here, which makes these negative. I'll have to fix that. But we're going to go ahead and type that in. We're going to do negative 15,358.93x squared plus 73,622.5x. And we're going to change our window because that's pretty big. So we're going to go from 0 to 10. That's fine. Let's go from negative. I don't even know if we need to do that. Let's go from 0 because really we're looking at a value there. Let's go by 10 thousandths. Whoops, I think I have an extra 0. Let's go with that. So we're going to go from 0 to 100,000. We're going to go by 10 thousandths. We're going to graph that. I know up here that it worked out. And then just remember how you find your maximum value. So here's our parabola. We're going to calculate our maximum. I'm going to go from 0 to 5, and I'm going to guess about 2.5, somewhere around there. Okay, so here's our maximum, 2.3967. And we have about 88,226. Okay, so go back to this. Determine the maximum revenue and how to achieve it. So if we look at the situation, our y value is going to be the maximum revenue. So on your graphing calculator, you should have this value. Here, what did I just do? So our maximum revenue is about $88,227, and that happens when x is about 240, if we round. Okay, and remember that x represents the price per box. So if we sell boxes of cereal for $2.40, that would result in our maximum revenue, which is about $88,227. Next, you have information here that you've probably seen before. The height s and vertical velocity of an object in free fall are given by the following functions. T is the time in seconds. G is either 32 feet per second squared or 9.8 meters per second squared, and it's the acceleration due to gravity. V naught is the initial vertical velocity of the object, and S dot is the initial height. So we're going to use those. Okay, so keep those there. You're going to use the data in the table below to write models for the height and vertical velocity of the rubber ball. Then use these models to predict the maximum height of the ball and its vertical velocity when it hits the face of the CBR. And don't worry about the CBR, that's old data collection that they used. So what we're going to do is first make a scatter plot of the data. So we're going to go over to our calculator, and I should have done this ahead of time to make it easier. But I'm going to go ahead and go to, hang on, where am I at? Go to Stat and Edit, and I want to clear what's in there. And I'm going to go ahead and pause the video just in the interest of time, and then enter this, and then I'll come back to it. So you do the same. Okay, so I went through and entered my list into my calculator. Hopefully you hit pause and did the same. Type those out. We are going to look to make a model for the height of the ball using a quadratic regression. So when we did this, I'm going to make sure my stat plot is back on, because I believe I turned that off. And then I'm going to go ahead and go to Stat, Calculate. And notice we did linear regression before. We're going to do quadratic regression because we want to look at that S of t, the height, and that is a quadratic model. So I'm going to do option 5. We're using list 1, list 2, frequency list I don't need. I'm going to store this into, go to vars. I'm going to star this into Y1. Okay, and then I'm going to calculate that. Okay, so here is what we would use for our linear model to write out our function. Okay, so we have negative 4.676 x squared plus 3.758 x plus 1.045 for our S of t. And I'll write that out on the next screen here in a second. So that would be an excellent quadratic fit. We could go ahead and graph that to compare them. Let's change our window a little bit because this is not going to show up. So we're going to go zoom 6, see if it helps. Okay, so notice there's a lot of information there. That is a quadratic model. Zoom in, you can see the scatter plot a little bit better because they're all decimals between 0 and 1 essentially, or 0 and 2. So you can zoom in a lot. Okay, so once we're there, we can use the information we have to write the other equation. Okay, so I'm going to go ahead and write this down. So I have S of t equals negative 4.676 x squared, or sorry, t squared, plus 3.758 t plus 1.045. When we do this, we took half of the g, which is our acceleration due to gravity. So if I double that that 4.676, I get 9.35, okay, which is pretty close. So we're going to go ahead and use that. So v of t, we are going to use negative g, and so when we took this leading coefficient and doubled it, we get 9.352 there times t. And then we use the initial velocity. Well, the initial velocity is the same as our initial velocity here. So plus 758 would be that model there. Okay, we are going to spend some more time on this tomorrow. I want to do more modeling just so you're comfortable with it. So try it, see if you can work with your calculator for it, and if not, we'll go on from there. Oh, sorry, one more thing. We need to predict a couple things. So we're going to predict the maximum height. So we can go ahead and do that using our calculator. I'll let you do that. And then I also want you to kind of see the downward rate when it hits the CVR. See if you can figure that out. I'm going to leave that with you. Kind of go from there. We will finish this up tomorrow.